The topic is infinite limits. So what we'll do here, I'm gonna try to show you that just by knowing a limit of 1 over u, as if you look at the graph of y equal 1 over x, you can tell that the limit of 1 over u as you approach 0 plus is plus infinity, because it's going this way. And then the same thing, limit of 1 over u as you approach 0 from the left side is equal minus infinity. And you can tell because the y value is approaching negative infinity. Now, just knowing this information, we will be able to evaluate the limit of f of x, any function, any rational function, as x approaching number, to assume a, and as long as the top approach some number, call it L, and the bottom approach 0, then we can evaluate that limit just by using these two limits. So let's do an example. For example, here we're trying to do for a, for example, one limit of 1 over x squared as x approaches 0 plus. So all I need to do here, I'm going to let u equal 1 over x squared. If I do that, this becomes the limit of 1 over u as you approach. Now x approach 0 from the right side. If you square that, u squared still approaches 0, and from the right side. Because if you square a positive number, you're still gonna get a positive number, and this is just a positive infinity. I'm using this one. Now same thing here. This is same thing as a limit of 1 over u. I'm gonna let u equal x squared, so u will approach 0 from the right side, because when you square 0 negative, then you'll get 0 plus, and this is going to be equal to positive infinity. So I'm still using the same limit. Right side and left side are equal to infinity, therefore limit as x approach 0 will be positive infinity. It still doesn't exist, but we know it's getting larger and larger with positive values. Now for example 2, we need to do limit of 1 over x minus 3 as x approach 3 plus. This time we're gonna let u equal x minus 3. So let me do this. So this is gonna be a limit of 1 over u as u approach 0. I mean, when x approach 3, x minus 3 approach 0. The only thing we need to know is it approaching 0 from right side or left side. The quickest way to find out, just plug in any number on the right of 3. For example, 3 minus 1. 3 minus 1 minus 3 is 0.1 positive, therefore 0 plus. And this is going to be equal to positive infinity. Same thing here. This is a limit of 1 over u as u approach 0 to find out if it's a 0 minus or a 0 plus. Plug in any number on the left of 3. So 2.9, for example, plug it here. 2.9 minus 3 is negative 0.1, which is negative number. So this is 0 minus, which is negative infinity. I'm using this limit. Now, right side is infinity, left side is negative infinity. So we say it does not exist. For example 3, well, I did this example just to show you it's not going to be always positive infinity when x approach a number from the right side. So here's a good example. This is going to be equal limit of 1 over u. I'm letting u equal 4 minus x. Right? I'm letting u equal 4 minus x. So u approach, we know it's going to approach 0. 4 minus 4 is 0. Now I want to know, is it 0 from the right side or left side? Plug any number on the right of 4. 4.1, for example, or 5. So 4.1 minus 4 is positive. Now I mean 4 on the right of 4, like 4.1. So 4 minus 4.1 is negative 0.1. So it's negative, so 0 minus. Therefore, this is negative infinity. Here it's the other way around. This is a limit of 1 over u. I'm letting u equal 4 minus x. U equals 0. If you use a number on the left of 4, smaller than 4 will be 3, for example. 4 minus 3 is positive, so this is 0 plus. You get positive infinity. Now for C, positive negative infinity, so as x approach 4, a limit does not exist. Now let's move on to example 4. Example 4. Here, let's do two substitution. This is the same thing as the limit of 1 over u squared as u approach 0. So I'm letting u, let me write it down here, I'm letting u to be equal 4 minus x. So as x approach 4 from the right side, use any number bigger than 4, 5. 4 minus 5 is negative, so this is 0 minus. Now I'm gonna do another substitution. This is the limit of 1 over t. I'm gonna let this time t be equal to u squared. So as u approaches 0 minus, t, which is u squared, is going to approach 0 positive, because when you square a number, it's going to become positive. And this becomes positive infinity. Same thing for this one. This is a limit of 1 over 4 minus x is u, so u squared as u approach 0. Now 4 minus x, I'm going to pick a number on the left of 4, 3. 4 minus 3 is positive, so 0 plus. I'm going to do another substitution. A limit of 1 over, I'm going to call u squared t. U squared to be t. Now t will approach 0. When you square something, it's still going to be positive. So this is positive infinity. Positive infinity from the right to left. Therefore, this limit as x approach 4 will be positive infinity. Now, I want to show you what if you have a negative number on the top. So this is the same thing as a negative 5 times the limit of 1. I can write negative 5 as negative 5 times 1. Just take a negative 5 outside. And this would be 4 minus x squared as x approach 4. Now I already know this limit. It's right here. I just did it. See, it is infinity. Negative 5 times positive infinity is negative infinity. Think of a large number multiplied by negative 5. Of course, it's going to be negative. So negative infinity. For example, 7. Same thing, I'm going to multiply 7 by 1. This is the same thing as 7 limit of 1 over 4 minus x squared as x approach 4. Now this is a c. I already did that, which is positive infinity. 7 times positive infinity, it would be just positive infinity. And a positive number times infinity is just infinity. And that's it for these examples.